some of you guys know, I'm Alim Gafar, and this is Adrian. About a month ago, we started talking about doing a talk together, and Adrian said, why don't we do it on ElasticSearch? And I figured, all right, well, just as good as anything else. It was interesting from my point of view just to see how to integrate this thing. I think you had an ulterior motive.
The key is to pick things that you need to do anyways for your business, and then it all works out. You get kind of paid to present. It's great.
Yeah. Well, I actually am going to use this in the Indie First Cut application that I'm building. So it'll have some relevance, but it was just sort of an interesting thing. So as he said before, there's been talks before about Elasticsearch in general, and this is sort of a sort of the wheels hit the pavement moment. We're actually going to walk you through putting the Elasticsearch into your application.
Eventually, we might just keep the title slide up for another 10 minutes. We'll see how it goes.
All right. So my name is Alim Gafar. As I said before, I have a boutique consultancy called DIRA Market Dynamics. We do market development for small companies and startups, and I'm one of the co-organizers. And you want to say anything about your firm?
Sure, yeah. I have a small startup called Share 911 that I co-founded about 3 years ago. I also maintain the roles authorization package for Meteor. And yeah, that's pretty much me.
Right. So, a lot of times we get up here and the speakers are up and they're sort of like seen as like gods or whatever. You're up here talking because you know so much.
Which is a totally thing. That's absolutely accurate.
And that's how we see ourselves. We're more like that, really, right? Which is, we're kind of curious about it. I mean, he was curious, I was curious, and so we just decided that we'd give it a shot. All right, there's some prerequisites that you need to have on your machine before you get started with installing this, and you should have a way to get at Elasticsearch. You need either using curl or homebrew. I recommend if you're running a Mac, use brew. It makes it a lot easier. You should be running Java on your machine. The recommendation is Java 7. Java 8 takes care of a lot of other things, and Oracle has a great build out there for you to pull it down. Obviously, we're doing this, I think, with the latest build of Meteor, right? Mm-hmm. So Meteor 1.2, no? You weren't?
Mm-hmm. 1.1.
You were doing it with 1.1? Mm-hmm. Yeah. All right, whatever. And Elasticsearch runs, and it binds when it runs on port 9200 and 9300 internally for its own use. So you should make sure that those ports are free. Finally, there are a couple of helpful tools if you have Chrome Canary and you want to use Postman as a means of getting data in and out. You should have that also. As Adrian had mentioned before, we're basing this off Arunoda's lessons that he gives in Bulletproof Meteor. And here's the coupon code. He's offering 300 free subs on this lesson. So you get them while it's available. Once this goes online and is on the Meteor YouTube channel, it's anybody's guess as to whether or not it's going to be available to you. Right? So once 300 is gone, 300 is gone. Okay?
Should we write that down somewhere? See us afterwards.
So the way we're going to approach this is we're going to give you a little bit of background on Elasticsearch, what it is, how it works, and so on. Show you a kind of pretty picture too on what it looks like conceptually. And then the meat and potatoes of this are the last 3 bullet points here, which is setting it up, integrating it with an existing application, and then actually that last item
maybe deploying if we have time. We'll go deploying.
That was a sort of a stretch goal. I forgot to take that.
Given that we started a little bit late, we probably won't get to that today.
That's right. Okay. So what is it that Elasticsearch does for us, and why are we actually looking at this as an option? And basically, it's a search engine. It's a standalone search engine that allows you to index and search. It's got full text search capability. It allows you really nice things like it does type ahead for you if you got it set up properly, and it helps take the load off your primary data source, right? So instead of doing all of your reads against that, you'll do them against Elasticsearch, and it makes it a little easier in terms of what's happening with your infrastructure. So, why Elasticsearch? I mean, you have a lot of different ways that you can go about this, right? You can, I'm a developer, I'm going to build my own search. I mean, that's an option, right? But it's one of those things that takes a lot of time, takes a lot of effort. The other options that you can go with is you could go with a competing product. There's Splunk, there's Solar, there are other things out there, there's APN and so on. Solar and Elasticsearch are both based on Apache Lucene. Solar came first. Lucene's been out since I think 2004. Solar came a little bit afterwards, and then Elasticsearch came out in 2010, and it's really robust. I think there is this DB Engines site ranks the engines, and it shows you where they place relative to each other, and they're more than the number that I have listed there, so you can go and check them out yourselves if you want to. But they also do an annual check as to where they stand, and apparently Elasticsearch is really has been the #1 search engine that's been used and deployed this in 2015. Finally, you could use a search service like Angolia, so you don't Algolia, Angolia is a place, Algolia, and I didn't spend a lot of time figuring that one out at all, but there are options like that if you don't want to actually do any of those building and doing anything about it. So we've decided to go with Elasticsearch, right? So as I said before, it's a search engine, it's open source, it's document based, it's really cool, and it's got its own query language. It's done in DSL, it's in JSON format, and you spend a little time with it, it becomes a little easier to use as time goes by. So it's out there. Who uses it? There are some big companies that are using it today.
Just a few.
Yeah, Stack Overflow, Uber. You recognize some of these names. I couldn't get everybody on, but these were some of the representative ones. All right, and as for what it is, you've got basically the client working with your application that then connects over to the server, and typical, infrastructure. This is a much larger deployment architecture.
So just to highlight this a little bit more, the Elasticsearch service is a separate server that will be running kind of like the MongoDB cluster does for your Meteor app. So you're going to be connecting to it. It could be running locally, which we're going to do tonight. It could be running in a hosted solution. So there's several different vendors that actually will host Elasticsearch clusters for you, and then you can just plug in the proper URL, the host, and they take care of the infrastructure for you. And to get back to one of the points that Alim made earlier, why are we doing Elasticsearch when we have a perfectly good MongoDB database, sitting there, which also does full text searching and indexing and stuff? Do you want to?
Well, first of all, Mongo is a database, right? It's doing a lot of other things. It's doing your updates, it's doing your writes, and so on. Whereas Elasticsearch is primarily just a search index. I mean, it indexes everything that you put into it immediately when you get it there. And that's all it does, is it hosts the documents, and it runs an index on it, and it's lightning fast in terms of return. In fact, I think it's almost more than magnitude.
It's
fast.
Really fast.
Yeah.
I view
that's
it as that's the key. Because it's so focused on this kind of searching and indexing, it's really fast. Yeah. Okay.
So what we're going to do now is, Adrian, are you actually going to do a setup on Elasticsearch, or we're just going to assume that we've already done
Yeah,
that?
we're going to assume that we've already set it up. I've already set up on my machine.
Okay.
And if you...
It takes a little while, and depends on also the network connection if you're pulling it over the wire. So
Yeah. If you are interested in running it, do they have a Windows installation? I don't know about that.
I believe they do, but I didn't look at it.
Okay.
At all.
Usually it's Linux, and Alim has actually done a lot of work on getting it working in a VM. So if you are interested in running it in a VM, is it a VM or a Docker file? I don't know.
No, I didn't do Docker yet.
Okay.
So I spent a lot of time. So here's the thing, right? I don't have Java running on my Mac. I didn't want to have Java running on my Mac, so I figured I'd spin up a couple of VMs and see whether or not I could get it running there, and then get it talking to my host machine. And I ended up doing that. So You know, all of these methods that you see up here, I've actually tested, run, and configured. And I know, like, I've worked out some of the kinks and the issues, and we've written some scripts that'll help you overcome some of those issues also that are available on our GitHub, Meteor-NY, GitHub account. So
you looked a lot younger in college.
I didn't test it with RPM. I didn't test it on Red Hat deployment, but it'll be fine. So in any case, basically what you do is you either do a brew install, you do apt-get, you do yum, you could curl and get it, and then just manually untar the file and then place it where you want to. I think in the cases where I'm going to make an assumption that when you did your installation, you basically did it local, and then you just did the bin/Elasticsearch directive?
I did brew install Elasticsearch, and then I typed Elasticsearch.
Okay. All right, so everything was set up nicely for you.
That's why I'm the presenter, because I'm the expert.
There you go. Right, so there are a couple of things that you need to do to test it. Adrian's going to walk you through that, and then finally we're going to just do the, putting it all together. So.
All right, so before we get to the actual app, we wanted to give you a brief rundown on actually putting data into Elasticsearch.
Yeah.
So we're going to come over to the command line, make it big so you can actually see it. We have it running. It doesn't like that I only have 17 gigs free, so it complains. It's pretty sophisticated. It'll try to reshard itself on other instances if it can. Let me see if we have actual data in here. Okay, so so this is the Elasticsearch index from the example app that we'll be going over later. And I understand this is too small, so I'm going to bump it up. Okay, so just to give you an idea of what this data looks like once it gets in there, the actual kind of document that you could think of from a MongoDB context is this, the underscore source part. So there you have your ID, you have your, this would be like a user accounts record. So in addition to that, they have these things called score, index, type, hits, and these kinds of shards things. So this is something we're not going to get into. Hits is really what we're interested in. The score is when you have kind of fuzzy searching, and it will use all of its awesome Lucene goodiness to predict what is the best match based on what you tell it in your query. But that can get pretty complicated. So the high-level thing to map in your brain from MongoDB to Elasticsearch is that in Mongo we call it a database. In Elasticsearch, it's an index. In Mongo we call it a collection. In Elasticsearch, it's a type. So here we have my index would be like my database, and the collection is the phone book. So in the app, we're actually going to be adding a user search to the existing simple to-dos example app. All right, so looking at how we did this at the command line, we did a get at the local server. Here is your database, here's your type, here's your index, here's your type, and then this is how you're telling it to actually perform a query, and you're just saying, give me it all. So that's like a star, like a select star kind of thing. And then this is just a nice way, if you have Python, then you can kind of pretty print the JSON. So another way you can do it is, instead of doing that, you can actually pass the ID itself to the get, and I forgot a quote there. All right, so then it gives you that, and we can pretty print it. And we have a nice looking thing right there. So these are two ways to do that. When you're updating, you're doing something similar, except you're doing post. And in the end, you'd be doing something like update and then passing it in the data that you want in in JSON format as the D things. If you want to remove a record, actually, if you want to delete an index, so we wanted to show you this because the Elasticsearch kind of front end tool you've seen, it's really giving this nice REST API. When you use the NPM node package, the Elasticsearch node package, it's just wrapping the REST API. So everything that you're doing from the command line with curl, you can also do from the NPM package, and also from this cool plugin called Postman in Chrome, which here. I have a couple of extensions. Sorry, I forgot how to actually open it.
There's usually
new tab.
Oh, okay. You lie.
there's usually a launcher at on your dock
Oh,
that
right.
it puts it in.
Okay. Down here?
Yeah. Do you see it?
Oh, the app launcher. Yeah. Okay. Cool.
There it is. Red button.
Postman. Nice. Thank you.
Welcome.
Okay. So basically, this does the exact same thing as the curl command line does, but sorry, I can't make this bigger. But you can. It's a little bit forgiving. You can actually like change, edit things, and you don't have to hit enter for every line and stuff. So you can set up all the different kind of commands. This is just a nice way to do REST kind of stuff. So it's nice for testing.
And it holds the history on the side for you. So if you want to go back and replay one of the directives that you executed before, it's right there.
Nice. And this is actually something that you'll do in the lesson. So you'll actually walk through some of these steps just so you have a better understanding of Elasticsearch. All right, so let's go back. I think we're actually at the point where we just do the app, right?
Yeah.
Okay, cool. Haha, the fun part. So like this app is way cool, and it's really impressive.
I'm going to mention something, by the way. When you do Arunoda's tutorial, it's going to mention that there are about 3 ways that he talks about of connecting Elasticsearch, the client, to the server. One means is actually not even connecting, but getting the data into Elasticsearch. One means is using a feature called rivers. I'm going to tell you right now, rivers have been deprecated. They're no longer supported by Elasticsearch, so you might not want to go down that path at all.
I'm actually going to cover that in here, or I can kick it to you and you can cover that.
No, it's okay. But I was just going to mention that. So what he did was he said, all right, what I'm going to do is I'm going to write to the database, I'm going to write to Mongo, and I'm simultaneously going to write to Elasticsearch, and I'm going to get my data in that way. And that's how he does it in his example. There's another way of doing it with collection hooks, and I think this is where Adrian decided to vary it a little bit.
Mm-hmm. Okay, so this is the app. You may recognize this from a Meteor Create example near you. But this one has, accounts password built in. Mm-hmm. Is that part of the example? Of the example one? Okay, so this one is one that
Yes.
Sashko did.
Yes.
Special. Okay. So he did the work of actually adding the user management part to the regular example app. And if you guys go to this location, DevShop, ElasticSearch, you can actually see this code, which I'm going to walk through right now. So from a high-level perspective, we see normal Meteor app, very simple, client, common, server. Let's look at common first. We've got collections and methods. Collections only have tasks, right? Very, very simple. Methods, we have a way to add a task, delete, set checked, set private. This is just the basic app. This is the basic app with no Elasticsearch stuff added in. If we look at the server, we have a method for adding and updating users. This is insecure. Don't do this. You should have your own authorization and security checks in here. We did it this way so that we can actually do that from the console and do some testing a little bit later. So we are publishing tasks. Say if you are the owner or if it's public, then you can see all of the tasks. On the client side, we have a body and we have a task template. So the body one is the basic structure. I'm going to pull this out so we can have side by side here. So we have all of this is in the head, and then very simple, straight up, each task. Let's check out what the task looks like. And then there's functionality to handle the events for clicking stuff, right? Making it public, private, that kind of thing. All right, cool. So that's the basic app. Now, if we go to number 1, the branch, number 1, then what we've done is we've actually added the ability to sync the data between the Mongo database and Elasticsearch. So this is like the first step. When you're adding it to your app, this is what you need to do first. Any data that gets written to Mongo also needs to get written to your Elasticsearch server. So let's look at how we did that. One thing that we don't want to do is have to update every place in our app where we write to the collection, because that would be kind of a pain. And this is actually what Alim was alluding to earlier about different ways of doing it. So let's see here. We got 5. Yep. All right, so when you are actually syncing this data, there's different ways to do it. So one thing is called rivers, which is kind of like what Meteor does with its own internal Mongo database access, where it kind of pretends to be one of the instances in the op log, and we'll just read that op log as it comes through. So a MongoDB river does the same thing, and it just sends whatever it gets to Elasticsearch. It's just kind of I'm not sure how that works filtering.
There's a plugin that's associated with that. And
so the important thing there is it's deprecated, so we're not going to touch it. Because we don't know how that's going to go forward. Another way you could do it is at the application level, you're going to hook in to the collections. So any time that you write to that collection or read from that collection, or I guess write to that collection, you can do something associated on Elasticsearch side as well. There are different ways of doing this. One of the easiest is a package called collection hooks, which you might already be using. One of the issues with using some of these kind of easier packages is performance. So it's not an immediate, you shouldn't use collection hooks. It's a look at your app, how you write to your collections. Are you writing whole documents at a time, or are you writing pieces of fields? If you're writing kind of incremental updates, like fields at a time, then you might want to use a different approach than collection hooks, because generally there is, for every update or every insert, there is a associated query. Because if you can imagine, in MongoDB you have an array that you have like permissions. So you are able to view the secrets, and then you want to add to that set the permission to manage users. So when that command goes to Mongo, you don't know what all the different elements in that array are unless you do a query. All you're telling Mongo is, hey, if it's not there, add this one little extra piece, right? So collection hooks, when you go to update Elasticsearch, it's not really made to say, hey, just add this one little piece. It says, oh, there's a little piece here. I need to go query the entire thing, and now I know the full extent, now I can just shove that into ElasticSearch. Yeah.
And I'm sorry, tell me if this is off topic, but so when you're talking about collection, does that also include like a kind of like a before insert, create like a relation?
Yeah.
If this is off topic, then
yeah, no, it's a good point. So so one of the things that's nice about collection hooks, and also things like the observe, which you're very familiar with Meteor, is it gives you that kind of previous and post case. So that's actually something that's configurable with collection hooks. I'm not exactly sure if you can ever stop the 2 queries. I think it always has at least 1 query. But for this talk, what we did is a little bit different. We did something that is recommended by the Meteor guide. Which if you haven't heard about is a very cool resource. This is actually something that I believe Sashko started, and it gives guidance. So the docs are great for giving kind of like API documentation, but a lot of people ask, well, what's the best way to do this? This is a opinionated version of the documentation that will say, okay, well, you have collections, and here's what you should do when you're in this kind of scenario. So what we're going to do is check this for what's called hooks. And if you're using ES 2015, then they have a really nice way to kind of hook in to this, this inheritance structure with this super command. For our purposes, we didn't want to say, because we're saying the goal is to add ElasticSearch to an existing app, probably a lot of existing apps aren't using that yet. So we just did the tried and true method of DevShop. Simply hooking in by Monkeypatching. So if you're not familiar with Monkeypatching, you remember the old one, and then you overwrite it with your own. Okay, and then you call the old one. This is kind of like that super call, right? And then here we can see we're actually doing the insert into the ElasticSearch using this ElasticSearch package, which is actually something that we did for this talk and for people to use. So if we look at this code, this is pretty much the only difference between the master branch and this branch. So we can see we added the ElasticSearch package, which pulled in some other things with it. And then we just added that one hooks file. So taking a look at that, there's an insert and there's an update. We didn't really get into remove since we didn't really care about that for users. But it's pretty straightforward, right? We got this API pretty good. You're just passing in the document. You're actually able to filter which fields because you probably don't want to store your password in Elasticsearch. There's probably some fields that you want to filter out. So that's built in. That's part of this. On the update side, insert is pretty easy. You just shove the entire document in there, filter it out, whichever fields you don't care about. On the update side, it's a little more complex because of that issue we were talking about, about these kind of like partial field updates. So how do you handle that? Well, the cool thing is that with Elasticsearch, you can actually enable this, this groovy engine built in. It's kind of like JavaScript, but it's this other dialect, this other language called Groovy, which you can pass it these scripts to do these kinds of same partial field updates and things. So you don't actually need to make that second query, generally. So you can see we're actually passing a selector and the mutator, just what came from the MongoDB update. And then what this function will do is it will try to pull out the IDs from the selector. And if it can't find the IDs, like maybe you did an update based on an email address instead of an actual user ID. But in Elasticsearch, your indexing, like your primary key is your ID, the underscore ID. So now we need to kind of transform from that. And this will take care of it for you, which is why we pass the source collection. So if it can't find the IDs in that selector, it'll go and do that extra query that it has to do. But at least it doesn't pull every field, it only gets the ID fields. And then the mutator one, it'll actually look at and we can take a look at that package later if we have time. But it'll do the conversion for you of, here's an add to set, here's a pool kind of thing. So so I hope you guys find that useful. It took some time to make. But really, that's the only thing that we're changing for this version of the ElasticSearch. So now we can actually see this running. We'll do a git checkout of ElasticSearch and 1. Go ahead and run that. You see ElasticSearch is still running. I'm going to keep this small since it's not really that important to go over. So we'll do Meteor Mongo. We'll see what's in our database already. Okay, so we do have some data in there. This is just stuff that I was working with earlier. So what I'm going to do is go ahead and reset that. Oh, right, because it's running. Well, the goal is to show you how to do this, like show you that it's actually updating. So let's go ahead and we'll just leave that in there for now because we'll do some updates from the command line or from the console. And what we'll do over here is do that query again. So we can see that right now our ElasticSearch index has a record for Roger and a record for Foo, 3B. It does not have a record for Foo2 or A Lanning because these records were added to to this database before we added that hook where it would synchronize. So this is something that you'll have to figure out on your own as well. When you add it, you have a lot of existing users that you will also need to figure out a way to spit that into the Elasticsearch side.
Is it left up as an exercise for the audience?
That's a nice way to put it.
Okay.
Okay, so I'm going to make this a little bit bigger. So what we're going to do just to prove that it is actually working, we're going to update one of these MongoDB records. And looks like we actually have the ID already. This was that super insecure method that we showed that just basically accepts whatever the client says and does it, which is always not good. Okay, so Roger Smith 2 and 61. So we're going to execute that. We can see that it happened. We have some console logging. So now we'll go ahead and check out our Mongo database. Make sure it actually got that update. So it got that update on the Mongo side. Now let's check on the ElasticSearch side. All right, so we've also got that on the ElasticSearch side. So you can see by just adding these few hooks, you've now accomplished syncing your data while it's happening to ElasticSearch, which is pretty cool. In addition to filtering the fields that you're interested in. Okay, so now that we've got that working, what's the next step? The next step is error handling. And before I do that, I actually want to stay in sync users so I can show you what happens when there's an error. So if you notice here at the bottom of this update, or at the bottom of this insert, we have this console log. And this is a kind of placeholder that is indicating, like, in a real app, you would probably have some things that happen in addition to just writing to Elasticsearch. you might be writing to another third-party REST call or something like that, or you might be blogging or whatever, sending an email, right? Somebody logs in, signs up, and you need to send them an email or something. So you can do that in your hook, but if you are just doing this like in a very naive fashion, then what's going to happen is, well, you can probably guess, you're going to error out before this gets accomplished, right? So you're going to have, if we look back over here, we can see that, okay, in the happy case, everything works. And now if we were to go back over to our to here, and we try to re-add Roger Smith 2, because Roger Smith 2 is actually the username, we expect this to fail. There's an error here, okay? And then what happened over here? So, so you can see this didn't rerun, which is actually what we want. But if we were to do an update on Roger Smith, let's say we're going to try to do Roger Smith 3. And let's just get rid of our Elasticsearch thing. So we stopped the Elasticsearch service. There was a network outage or something, right? Your app can't get there. So now what's going to happen? So now we get this internal server error, and not only did we fail to write to Elasticsearch, we failed to continue with that super important third-party REST call. So all that stuff that happened afterwards. So there is a solution for that, and it is error handling. So when you are doing this, there's kind of two stages here. There's the stage where you want failures in Elasticsearch to not screw up the rest of your application, but you also want failures in your application to not make the data in Elasticsearch get out of sync. So when could that happen? So when an update fails, for example. So perhaps you have a user who is changing their email address, and they try to change it to an existing email address, right? But we have a restriction on the database that says, hey, email addresses have to be unique. So what's going to happen is that your first call is going to fail, but if we weren't careful, we might actually succeed on the updating the Elasticsearch with that new email address, and then your data is out of sync, and that's going to be a real pain for you. So this is one way that you can help avoid that. So we have Elasticsearch errors, which we basically just eat, and this is where you would do things to help yourself ensure data consistency. So you probably want to log this to a special log, or email somebody that, hey, there was an updated attempted. The data in the database was written successfully, but now you need to go back and clean up your Elasticsearch side. And then we also have the case where it's a database error, and these we need to rethrow so that the clients get that, oh, the email address is already in use, and then you have a nice pretty printed message over there. All right, so one of the cool things about what we just looked at is this is all happening in one file, this hooks file, and we didn't have to change the rest of the app to make this happen. Like that's really cool. Like that's a sign of a good design, when you can isolate your changes in one section and not have to worry about other things. Okay, so now that we've got error handling handled, you can check out the final piece of the puzzle. So let's go ahead and switch to the final one. I'll go back to the top so we can compare. This is actually comparing against the master branch, not the branch that we were just looking at. So some of these things are the same. You can see we actually added a new package, Reactive var. Now we're actually adding our search box. We have a search template. And this is on the client side, how to get this search thing working. So here is a new call for get users. This is where you're actually calling on the server the method that will perform that query for you against Elasticsearch. get back the data, and then we're putting that in a reactive var so that our UI knows when that's coming back. So this is kind of like how in Meteor land we deal with asynchronicity, asynchronous behavior. Instead of a bunch of callbacks, we can use the reactive nature or reactive tools that Meteor provides us to make it a lot nicer to do this stuff. So let's take a look at what get users is. This is the same, the hooks one. So here we added a new method on the server side, which is where you're going to do your querying. So this is an Elasticsearch query, and it's pretty weird. This is just something that you're going to have to learn, or use your Google foo to find other people that have tried. How do I do type ahead lookup for users or first and last name kind of thing? And this is something that that in the Bulletproof Meteor lesson, Arunoda gives some links that you'll go into the documentation and learn more about the query DSL and these kinds of things. But a lot of the time, a lot of your time is probably going to be spent here versus just hooking up the data, syncing and stuff, which is pretty much a solved problem now. We just showed that you can get that going really fast in your application. So it has this concept of different types of queries and must versus should, so that you can get those differences in the score, right? So must means it's a hard requirement. Should helps you to rank between different things that might, like a user has the same last name. So how do you decide, between a bunch of them, which one should it return first? So we're just doing this. You can see we're digging in to the hits, which if you remember from the very beginning, that's kind of the format that it gives you back. And we can go ahead and take a look at the app. Cancel that. Check out ElasticSearch final. And run. So can you guess which one of us is the graphic designer? If you guessed neither, then you're right. Yes. All right, so we know that there's a Roger in here somewhere. I thought there was a Roger in here somewhere.
Turn on ElasticSearch.
Oh, thank you. This is what it says when you turn off ElasticSearch. No living connections. But the cool thing is, the rest of our app didn't die and blow up on us. So here's what Alim was talking about earlier. First it binds to 9300 and 9200. These are just the defaults. Of course, you can change it. So now it's running. Go ahead and clear this. Our app is still running. And let's see if it automatically connects. Yep. Okay, so it automatically reconnected, which is pretty awesome. So there's Roger. If we were to go ahead and update that to Roger Smith 3, which we tried to do before, but was off. We had it turned off at that time, so it failed. Now it should have succeeded. So if we go ahead and search again, we know that ElasticSearch has that data already resynced, and the new query pulls the resync data. So that is adding ElasticSearch to an existing app. And you can see there's not much to it, right? It's pretty straightforward. The hard part is going to be figuring out exactly how to tailor that query to get you what it is that you're looking for. Yep, and that's the end of the app part.
Right. So one of the things that should be clear about here is Adrian actually built a new package to make this a little bit easier. And what's it called? Is it?
Yeah, so let me go back over here.
ElasticSearch Meteor, Meteor ElasticSearch, something?
Yeah, it's just creativity, not the most original of names. Yeah, it's cool.
There are a number of ElasticSearch options out there. in Atmosphere right now. They're about 44 something when I do a search on them. But as you were saying, this addresses a specific problem, right? Which the others, well, we don't really know very much. You said you searched around, you took a look through.
So before I wrote this, I actually, because I had to use this for my application, I was very interested in not recreating the wheel. So I did kind of do a search first, and this was kind of the coolest one that I found. And he actually released it very recently, 4 days ago. It's very reminiscent to me, of the collection hooks side. So he's actually using an observe here. But what I found consistent with all of the existing packages was that they also require that kind of old and new query. So you kind of have to already have the data, and that might not be a bad assumption for depending on your app, right? You might actually be updating things that Meteor itself already has in its own internal cache, and you're not, it's not the end of the world to ping that again or get an update. Or if the data is changing in the database, it might already be coming into your server side. So, think about what your app is doing before you kind of make these decisions. But the cool thing about what this package does, if we can reconnect to Atmosphere. Or we could just go directly to the repo. Oops, that's not the repo. Name spacing. Okay. I'll go ahead and show you the documentation, because that's probably the easiest way to do it.
So essentially what ended up happening was this tutorial became the genesis of this new package. Started out with trying to explore one thing, and then Adrian decided to build packages.
Not Adrian decided to. Adrian had to, because for my work I needed it anyways. And I couldn't accept having to make 2 queries every time we did an update. Because a lot of what we do is very small, little partial updates, so we're not updating the entire document a lot. So you can see here the insert function that we used, the partial update function that we used, and internally it is using this MongoES function, which will actually do this conversion for you from the MongoDB side to the Groovy, which ElasticSearch actually understands. And it's it's fairly full-featured. It can do things like add to set with an each clause, or I guess a pool with an each clause. It understands that. It can understand the difference between numbers and text and stuff like that. So yeah, I hope that you guys find that useful. Feel free to send pull requests with your own things that you find useful. And if you really need to get down to the core client that is coming from under the hood, this is using the npm Elasticsearch package, and you can get access to that with these two. The difference is that this is the raw one from npm. This is the one that has been async wrapped, so that you can actually use it in your Meteor apps, because most of npm stuff, it's async. It's dealing with promises and callbacks. But in your Meteor app, because each connection runs in its own fiber, we have this nice concept of synchronicity. You can actually write as if everything was synchronous without harming throughput. Okay, so yeah, so that's the package.
Yep. So that's basically the talk. These are I don't remember which one of the of the lessons you're actually getting for free, but these are the two that are related on Bulletproof Meteor.
Yeah, you're actually getting this one for free, which is better, because this is the one which is just the regular, I believe this is the one that's just regular Mongo, and then this is the one when you're actually using the ElasticSearch capability. So
Right, so they're both there. By the way, you know, when I went looking at this, this was before you offered the freebie. You know, Adrian said, you know, you should just get the stuff because it's like only $89 for the whole package. So I ended up buying it. So it's actually very useful. And yeah.
yeah, and we're not getting paid to say that.
No, but it is very useful, and many other people feel the same way. So the last couple of slides are just a set of resources that that we walked through in the application, and that is it, right?
Yeah, and we'll provide the slides online.
Yep.
Yeah, if you guys have any questions about Elasticsearch, adding it to your apps, feel free to get in touch. Specifically, if you're using, interested in doing VMs, Alim has a lot of experience with that.
The VMs were really more as a means for separating out the Elasticsearch server from running your client. So.
All right, thank you very much.
Thanks.